This is One Small Bridge for Man, One Giant Bridge for Mankind by Matt Bark. For my bridge, I use two Maryland core technologies, structural and materials technology. Materials technology is technology of producing, altering, and combining materials, and I used it in my design process by cutting wood into pieces of different lengths, as well as combining wood and glue to build the bridge. Structural technology is the technology of putting parts and the materials together to create supports, containers, shelters, connectors, and functional shapes. I use structural technology in putting the pieces of wood together. Many different kinds of bridges can turn out to be very successful. This not only allows for success, but also allows for uniqueness around the entire world. There are four different types of bridges: arch, beam, suspension, and cantilever. Some notable arch bridges in the world include the Chiaottiana Bridge, located in China, and the Ponte Vecchio Bridge, located in Florence, Italy. Some popular beam bridges in the world include the Fuller's Bridge in Wales and the Albert Bridge in London. There are also many well-known suspension bridges in the world, some of which being the Golden Gate Bridge in San Francisco and the Brooklyn Bridge in New York. Cantilever bridges are also still used today. Cantilever bridges around the world include the Forth Bridge in Firth of Forth and the Quebec Bridge in Canada. There are three types of trusses used in different bridges: Howe, Pratt, and Warren. The Howe truss is identifiable for the X's on the sides. The Pratt truss is distinguishable for the diagonals pointing towards the center of the bridge. The Warren truss is known for the W's on the sides of the bridge. For bridges, there are also three types of roadways: deck, pony, and through. A deck roadway is where the cars drive at the highest point on the bridge. A pony roadway is just like a through roadway, except the material above the roadway is not connected. A through roadway is where there is excess material above the roadway on both sides that are connected by bars extending straight above the roadway. There are four different types of forces that a bridge must withstand to hold tons of weight: tension, compression, shear, and torsion. If a bridge cannot withstand any of these four forces, that will result in possibly hundreds of thousands of deaths because the bridge will not stay intact. Tension is the pulling of a material in two opposite directions, causing the material to stretch. Compression is the pushing of a material into the center, causing the material to compress. Shear force is the tearing of a material, and torsion is the twisting and turning of a material, pictured here acting on a real bridge. To begin the design process, I had to decide what kind of bridge I wanted to make. I had to factor in which would weigh the least while remaining very effective and strong. To design my bridge, I used West Point Bridge Program and then transitioned into Vectorworks to make a scale blueprint. I decided to make a beam bridge with a Pratt truss. I printed the blueprint and began building the first side over the blueprint with wax paper. After the first side was completed, I applied gussets at all of the points to strengthen the joints. I then had to repeat the process with the second side. I did the exact same thing, and then had to connect the two sides, and that would be that. I cut 30 1/8 inch pieces of wood spanning 2 1/4 inch long to connect the bridge. Then I began the testing process. First, I had to weigh my bridge. My bridge weighed 20.5 grams. Then I placed my bridge on the testing site and attempted to completely destroy my bridge.
That was great. Really bad.
The break in my bridge was ideal. It did not break in the center, meaning it survived the forces of tension and compression. However, the bridge had breaks on the ends, meaning shear force was the reason for those tiny breaks. Then I calculated my efficiency rating by doing the load on the bridge divided by the weight of the bridge. My efficiency rating was 5,766.12, putting me in fourth place for bridge efficiency in my class.